Okay, now we will learn about a spherical mirror. We have two kind of spherical mirror. One is concave and convex. And what a spherical mirror look like. So this is, for example, a mirror because it is reflecting, and we can see our image in this surface and also in the inner part of the mirror. Okay, so the spherical mirror is characterized whether it is in this side or in this side. So this is a convex mirror and this is concave mirror, and we can have various radius of or curve of mirror. For example, this mirror, it has a large radius instead of this, you see, and they may have a different image form for the same object. Okay, so so in general, spherical mirror we have concave and convex mirror, and then let's look what would be the general difference between those mirrors. So this is convex mirror, okay, in this side, and we have a flat mirror, plane surface, and also a concave mirror because it is a little bit curved toward inside, so it's not a plane mirror. So if we compare between these three, okay, so it looks to my finger. So this is our the image of the finger will be smaller. This is in the same size because of the plane surface, plane mirror, and this will be large for concave mirror. So you see the property of the image, or the characteristic of image change with the shape of the mirror. Okay, so that's me. So after this, we will learn at what position or what are the characteristic of the image formed by convex mirror and concave mirror. So we have learned about the plane surface in previous topic. Okay, now let's start. Before we proceed, we have to understand ray property at a distant for a distant object. For example, we have for example, this is sun as an object emitting light in all direction. So it emits light in all direction. So take for example, we consider only three rays from the sun, and the sun is very far away. So the ray will be emitted, for example, in this way, and also in these two ways, where this is this ray is perpendicular to the surface. Okay, so and then if we are far away from the objects and we look into the small part of the ray, and this position is very far from the object. If we look into this area, we can see that this ray is parallel, but actually it's not parallel. If we look here, it has some angle difference, but at very far away from the object, we see that these rays are parallel. So rays coming from object at infinity, or this is object distance at infinity. If the object is at infinity, the rays are parallel. I say this is parallel because it is actually approximately parallel. So this property is important to understand how concave mirror and convex mirror behave. Okay, now we keep in mind the rays are parallel for the object at infinity. So next, we want to explore more about the mirror, the spherical mirror. So we start with the concave mirror, okay, where the object is at infinity. Alright, so this is a spherical object, for example, the reflecting surface, and it's reflecting. So for concave mirror, we take a part of a spherical, so this will form a concave mirror. Okay, for example, like this. So this is the concave mirror in this part, inner part. Okay, it is a part of a spherical ball. Okay, So it looks at this mirror we sketch. We want to make a ray diagram to study about this concave mirror. Okay, now let's consider that this mirror will take ray from infinity. Okay, so for example, we want for example, the light from infinity go to a concave mirror here. So what will happen to the reflected ray? Okay, now what we want to do is that we want to predict what will be the what will happen to the reflected ray. Okay, so let's consider first the first ray coming in this direction. Okay, toward the mirror. Okay, so of course, when it hits the mirror, it will be reflected. But in which direction it will be reflected? Okay, so this is the C, what we call as a center of curvature. Center of curvature, or actually the center of the sphere. Alright, this is C, and then to draw the to predict where would be this incident ray reflected, we have to draw the normal line to help us. So the normal line at this point is actually a line where it will goes to the center. So that is the normal line. So since this is a normal line, so we can see that the incident angle is 0, so that the reflected angle is also 0. Then the ray will be reflected back, passing through the same path. Right. Okay, now consider another ray. For example, a ray from here about okay, let's say 3 centimeter from this axis. So this axis is called as an optic axis. Optic axis. Okay, go to, so I extend a little bit the mirror so we can see more clearly. Alright, so this is 3 centimeter from the optic axis, so it will hit 3 centimeter from the optic axis. It will hit here. Okay, so let's draw this second ray. Okay, this ray, this is second ray, this is the first ray. Okay, now where will be the reflected ray go? Okay, then to know that, we have to draw the normal line first. So remember that for the spherical object, so the normal always directed to the center, because this is 90 degree. Okay, this is the normal 90 degree. Alright, so you see this is incident angle theta I, and that's mean we know that from law of reflection the theta R would be the same, so it will go directly here. This is the second ray. So let's take another ray. We can draw as many as we want, but this is just to demonstrate what happened if we have only 3 rays to represent all rays coming from far away hitting the concave mirror. Okay, the third ray maybe is a ray of about 1 centimeter from the optic axis, maybe here. Okay, so let's draw here so that you have a ray coming from here, hit. Okay, this is the ray number 3, hit the mirror and then get reflected. So how? Again, we must draw the normal line to help us. So this is our normal line, always directed toward the center. Okay, you see this is the incident angle, this is the reflected angle. Okay, so by drawing properly, this angle is actually will go in this way. Okay, so if we draw many rays, all of these rays will be focused at this point. So this will be a focal point of the mirror. Okay, focal point of the mirror. Alright, okay, so from here to here, this is a radius of the mirror, and then from this to here, this to here, this to this point, this is point V, or called vertex. Okay, so from here to here, the distance is f, small f, which is the focal length. Alright, so if you look here, the focal length and the focal point is exactly in the middle between the center and the vertex. So we can have a relation where the radius is equal to twice of the focal length. Alright, so this is the first relation for this concave mirror. So the f is half of the radius. And then by our convention, this focal length is positive, because you see the radius is positive. The radius is positive because the outgoing rays is in the same side as the center. Okay, so where is the outgoing rays? So these coming rays are called incoming rays. And then the reflected rays are called outgoing rays. And the outgoing rays, we see that outgoing rays is in the same side as the C, as the center of curvature, so that R is positive. If R is positive, the focal length is also positive. So for concave mirror, the focal point is positive. Okay, what is the application of this concave mirror? For example, if we have a TV dish, for example Astro, any satellite TV, so the light from the satellite, it emits a radio wave, and this radio wave is parallel at far distance and will be focused at one point. So for our TV dish, we have a receiver which is very close to get this radio wave intensified and collected by this receiver. And also a spotlight in front of our vehicle, our car, the LED, or the light source will be placed at this point, and it will be reflected and goes away. It's like a inversion of this incoming rays focus. But for the spotlight, the LED will emit light in all direction, and will be reflected in a parallel direction in a nice way, instead of diffuse this in all direction. Alright, this is for concave mirror.